Alright, welcome to the practice problem video for section 6.2 about potential energy. Alright, so you've probably watched some of the videos over potential energy in the assignment, and you've seen that potential energy is basically the potential for an object to do work. Now, if you are watching the video, this might have confused you just a little bit. In the videos, it said potential energy is equal to weight times our height. Okay, and you're looking at this and you see that the only equation on here is potential energy is equal to mass times gravity times height. Now, don't be confused for too long, okay, because essentially mass times gravity right here is our weight. So the equation that we're going to be using in here basically has the weight part already built into it with our mass times gravity. Okay, so looking at our equation here, let's look at all the pieces that make it up. So potential energy is measured in joules. Mass, the M, is measured in kilograms. G is gravity, which in the video says is 9.8, but we've been using 9.81, so pretty much the same thing. And H is our height, which is measured in meters. So this is our basic equation. Potential energy equals mass times gravity times height. Now, we can make a pretty funky equation triangle for this, and we have that right here. So the rules for this are still the same with equation triangles. Let's say we're trying to find, let's say the gravity. We would cover up what's missing, and what's left over is what we need to do to solve the problem. So like for this one, if we're, again, looking for the gravity, we would take our potential energy and divide that by our mass times our height in order to get our gravity. Okay, so this equation triangle, if used correctly, tells us exactly what to do. And let's see that in action with our practice problems. Okay, so the first example problem is right here. It says, how much potential energy does a 20 kilogram object have if it's 15 meters off the ground? Okay, so looking at this one right here, it's looking for potential energy. We don't know what that is. 20 kilograms is our mass, and the height is 15 meters. Now, you might be thinking to yourself, okay, we have potential energy, we have our mass, we have our height, but what's G going to be? Okay, since we are on Earth 9 times out of 10 in these problems, gravity is going to be equal to our 9.81. So we follow the same steps as we usually do. We're going to, if we cover up potential energy, okay, so we're going to cover that up. Try to here. Okay, if we cover up the potential energy, we're left with mass times gravity times height. So for this problem, we have 20 times gravity, which is 9.81, times our height, which is 15. So if we punch this into our calculator, we get 20 times 9.81 times 15 gives us a total of 2,943 joules worth of potential energy. Okay, so all we had to do there, looking for potential energy, is just multiply the three of them. All right, let's see if I can, good. Okay, so now for the second one, we're going to be using the same thing. So let's get a fresh copy of this equation triangle. Let's try again. Fresh copy of the equation triangle. There we go. So we're going to move this guy over here. Okay, so on this one, it says how far off the ground is a 10 kilogram pumpkin if it has 1,200 joules of potential energy. Okay, so right off the bat, We know we're trying to find how far off the ground. That is our height. 10 kilograms is our mass, and we have 1,200 joules of potential energy. Okay, so on this one, we are missing, well, it's asking for the height. So to solve the problem, we need to do our potential energy divided by our mass times our gravity. Okay, and that's just what our equation triangle shows here. Potential energy divided by mass times gravity. So if we set that up, we have 1,200 divided by our mass, which is 10, times, since we're on Earth, gravity is going to be the same as before, 9.81. So times 9.81. So I'm going to show lots and lots of work. 10 times 9.81 is going to be 98.1 on the bottom, and the 1,200 goes across also. So now we just punch this into our calculator. 1,200 divided by 98.1 gives me my answer, which means this pumpkin is 12.23 meters off the ground. Okay, so that's going to be my answer for this one. Okay, so for these problems, they're not bad. All you got to do is use your equation triangle. Okay, remember, cover up what's missing, and what's left over will tell you exactly what to do. Okay, so all of the problems in section 6.2 use this equation triangle, and the only ones that might throw you for a loop are the ones that are asking for gravity. And those aren't hard. All you do, if it's looking for gravity, let's see here, give you an example here. If it's looking for gravity, all you do is cover up the g in our equation. And so if you were looking for gravity, you would do potential energy divided by mass times height gives us our gravity. So that's how you do the ones that might mess with you a little bit. But that's all I have. Good luck on the problems. Let me know if you have any questions, and thank you for watching.